Alright, so your question was about a function that looks like this, 6 times quantity x minus 2 squared. So, what we need to do, since we're doing transformations of functions, is to figure out what in the world our original function was supposed to be. And since this has an x in it and it's squared, that's our original function. So I'm going to graph that in blue. I'll call it g of x. Since I've already named this one f of x, you just put a different letter on it to indicate that it's a different function. So that one is x squared. Those are our parabolas. And 0 squared, if you want to do a table of numbers, would just be 0. So I can put a point there. 1 squared is 1. Negative 1 squared is also 1. 2 squared is 4, so if I go over to 2 on my x-axis, go up to 4. Negative 2 squared is also 4, so you can see the parabola forming here. And I will try to draw this as neatly as I can. There's our original function, basically. That's our parabola. So what we have done to it with the 6 on the outside and the minus 2 with just the x, that part, it means that we have a horizontal shift. So the minus 2 is a horizontal shift. So I'll write that down. Anytime we add or subtract just from the x, that's going to be a horizontal shift. Horizontal shifts kind of work backwards from what we're used to. The vertical shifts move up or down just in the way that we would think they should. If we add something to a function, we would move it up that many spaces. If we subtract something from a function, we move it down that many spaces. But horizontal shifts are kind of backwards from that. And since this one has a minus 2, we've subtracted 2 from our x, that's going to be a horizontal shift 2 spaces. Instead of back or to the left, we're going to move 2 spaces to the right. And when you have more than one transformation that you're going to do to a function, we have to take a look at the order that we're supposed to do those in. And the order for those, I usually just write it down. I remember HSRV. And the H stands for horizontal shifts, which is what we're going to do first. And that we do have one of those, so we'll do that first. And then the S stands for stretching or shrinking. When you multiply, like we did, we're going to do some of that. So we'll do that. We don't have any reflections. We don't have any negatives in there. And we don't have any vertical, which is what the V stands for, vertical shifts, because nothing is added or subtracted from the entire function. So we've got one of these and we've got one of these. So we'll start first by doing our horizontal shift 2 spaces to the right. So I'll just move all these points that I've put down 2 spaces to the right. So that one, it was at the origin, I'm just moved it 2 spaces to the right. If I take this point here and move it 2 spaces to the right, it goes here. And if I take this point here and move it 2 spaces over 1, 2, it ends up where this one is. So I'll put that one there. And you can do that with all these points. And then you get your new parabola. I'll try to trace this as best I can. So that is our first shift, or first transformation rather, and it's our horizontal shift to the right. The next thing we're going to tackle is the 6 that's multiplied out right there, and that's going to be our stretch or shrink. Now, to figure out what we're going to do with that, when we multiply the whole function by something, that's a vertical stretch or shrink. In this case, since it's a number that's greater than 1, it's going to be a stretch, a vertical stretch. What we do, since another name for f of x or a function is y, you could say y equals all this. When we multiply the whole function by something, that means that we should multiply all our y values by that number. So we're going to multiply the y values of our new points, the ones that are in red, by 6. And then we'll be finished. So if I look at these points, this one is 2, 0. So if I want to write that down, 2, 0. If I multiply the y value, which is the 0, by 6, it's still 2, 0. It doesn't do anything to that one. So that one will stay right where it is. So I'll put a green dot there to indicate that still stays there. The next point I have is right here, and I'll label that one. That one is 3, 1. So if I multiply the y value, or the 1, by 6, I should get 3, 6. So I'm going to go over to 3, but I'm going to go up to 6. So my new point is at 3, 6. And then if I do that with this point over here, which is 1, 1, if I write that down, 1, 1, and multiply the y value, which in this case is a 1, by 6. 1 times 6 is 6, so I should go 1, 6 for my new point. And so if I graph those, because if I try to do some of the ones that are up higher, I'm going to go off of my graph, my coordinate graph here. So I'm just going to try to redraw that one, which I didn't do a very good job. But anyway, hopefully you can tell. It's kind of like I anchored this vertex here and just pulled on either side of my parabola to stretch it vertically. But that's how you do it. It's not too bad if you can remember the steps. And I would go through in your textbook, or the one that you can access online has that on there, and the different transformations and how they work and what you to do with those. And there's also one of the PowerPoints has that, the one for 1.6 has that in there as a full sheet that has all of your transformations all on one page, and what to do with those. So I hope this helps. Let me know if you need more.